though I'm sure there'll be a few folks still to come in. Very warm welcome to everyone for this inaugural public lecture of the 2-week STEPS summer school that we're running from this day to the next couple of weeks on pathways to sustainability. And we're really honoured to be able to kick it off with our guest speaker today. It's always a real privilege and a pleasure to introduce Michael. But today more than ever, because Michael has soldiered down here with a Pavlovian reaction there, with a cold that really should have him in Hackney wrapped up with a hot water bottle. And we are very, very grateful to you, Michael, for coming down to speak to us today with Spartan stoicism on capitalism, carbon and climate change. Michael, I'm sure, doesn't need much introduction here, but I'll just say a few words by way of context. Going back to the 90s, Michael is the author of a series of works in ecological economics and the green economy that have been formative on many debates. He then went through a very influential career, starting off or co-starting the Real World Coalition, which many people may remember, General Secretary of the Fabian Society, from there went on to the Council of Economic Advisors at the Treasury, and then a period as the advisor in number 10 to Prime Minister Gordon Brown, and now visiting professor at the LSE Grantham Centre on climate change. So it is an enormous pleasure, Michael, to introduce you. Thank you for coming down, and we look forward to what you have to say.
Thank you. Thank you very much indeed, Andy, and thank you all of you for coming. If I speak with the mic, that's better, isn't it? I will take lots of sips of water during this, so you'll have to forgive me if my voice gives up occasionally. I don't know whether you heard Andy say that it's always a pleasure to introduce me. This is because I was here last year too, which is a great privilege for me, but does show a rather lack of imagination on Andy's part, in my view, in inviting. But it is a great honour for me to come back. But it also poses a bit of a problem, since I do like to start these talks, particularly the ones about economics, which is not a very funny subject, with a joke. I've been collecting jokes about economics for about 20 years now. I have 4. And unfortunately that was one of them. And one other of them was presumably the one I gave last year. I can't remember which one it was. So for those of you who were here last year, let's hope that this one wasn't it. So this was a story told by a friend of mine who was very privileged he was a former diplomat who served in North Korea, and he was very privileged to have been invited back last year to a very important day in North Korean history, which was a celebration of its founding, which he sat next to some of the diplomats in the diplomatic corps at a huge military parade, at which the North Korean military, which of course is a great pride in North Korea, as you can imagine, was paraded past King Jong-il and the other members of the ruling elite. And as he was described to him what was going on, it was said that if you follow this parade, you'll see that it goes up in order of military capability. And duly, indeed, the first people marching past were some foot soldiers with rifles over their shoulders, and gradually went to the artillery, and some tanks came along, and then some huge, great rocket launchers, and eventually some short-range missiles, and eventually, finally, this massive, great intercontinental ballistic missile, the pride of the North Korean force. And my friend watching this had taken for about 3 hours, lots of applause, lots of standing up to salute, assumed that it was all over with the intercontinental ballistic missile. But then noticed that behind this huge, great missile was a little jeep, driven by a driver in military uniform and a couple of rather dishevelled-looking middle-aged men in the back. He said, what is this? Who are these people? They're coming after the fantastic power of the intercontinental ballistic missile. His North Korean colleague turned to him and said, "Never underestimate the destructive power of the economists." So you better not invite me again, Andy, otherwise we will completely run out of the economics jokes. I want to talk about the economics of climate change, and to try and relate this to the wider economic crisis through which we are living, showing both how both require new ways of understanding and thinking about capitalism and the creation of value in society. In our thinking about economics, but also our thinking about politics. I want to start with some slides. The first half of my presentation is going to have some slides, and then I want to just, without any slides, offer you some reflections on where I think our understanding of climate change now can lead us in thinking about wider questions of political economy. The currently dominant view, of course, is that climate change and our economic situation are now facing in opposite directions. Since the recession started to bite in this country and in most of the developed world, climate change has slipped rapidly down the political agenda. Indeed, now we are in the UK in something of a backlash in which prominent members of the government, of the Conservative Party, and of the Conservative supporting media are now openly and actively questioning what had been a cross-party consensus on the move to decarbonising our energy system, and are arguing not just that those costs cannot be afforded, but indeed that the science may no longer be reliable. And this is having a rather disastrous effect on energy policy and on the investment in the low-carbon economy, undermining investment actually in one of the few growing areas of the British economy. But that is a debate for another time. You may wish to come back to it. What I wanted to do first was to just remind ourselves, because it has slipped down the political agenda over the last few years, what exactly has been happening in the climate change field. Sorry, can we get that back into the... No, it doesn't work. Aha, there you are. So just a few slides, just to remind you. I'm sure you're familiar with much of this, but just so that we are clear. This is the global temperature change. There's been quite a lot of discussion led by some climate skeptics that there has in fact been no warming in recent years. But the trends are pretty clear of rising temperature, and we know why. This is the record of carbon dioxide in the atmosphere. I need to update this. I don't know whether you saw that in the last week, atmospheric concentrations have now hit the very top of this graph, 400, which is only at the same rate that they've been rising over recent years, but is a kind of symbolic moment at which atmospheric concentrations have gone above 400 parts per million. And we know where these emissions come from a whole variety of sources, from energy, from fossil fuel use in energy and industry, from deforestation, agriculture, and so on. We saw last year the melting of sea ice in the Arctic to record levels. The average from the last 20 years is the red line around there. The white area is what happened last year. So this is a very considerable increase in melting. And what's significant about this is that this conforms to the modelling of what would climate scientists expect to happen. So this shows a range of possibilities from the models, and the blue line here shows actually what's happening. So it's actually now going rather faster than the models predicted. And we know now, through the probabilistic models that climate scientists use, what the range of emissions pathways are, which are likely, under various probabilities, to hold temperature to different kinds of increases. These lower ranges down here are consistent with the temperatures here. This is where we are. Our current expectation is to be on one of these trend lines. So we have a huge amount of work to do to get off a business as usual path, which is taking us to very considerable temperature rises of probably 4 to 6 degrees. This is a very simple way of understanding how far we are off the trajectory towards the 2-degree mark, which is what the international community has decided is the maximum safe level towards which we should be aiming. Some countries think that 1.5 degrees is better. That is mainly the countries who will be inundated by rising sea levels at 2 degrees. So this shows what we would need to be at in 2020 to be on a reasonable probabilistic path to a 2-degree world. And the figure for 2020 is that we would need to be emitting in total globally 44 gigatons of carbon dioxide equivalent. If we carry on in the way we are currently, so if current trends persist, we are expected to be at around 58 gigatons in 2020. If countries implement all the pledges that they've currently made under various domestic and international commitments that they made, this might take us to between 52 and 57 gigatons, which depends on how stringently they implement their own pledges, which gives us an emissions gap between what we would need to be on a 2-degree compatible path and what we are likely to be in 2020, even under the best of scenarios of implementation, of between 8 and 13 gigatons. And this kind of analysis is sometimes called the emissions gap. This is a report which is now produced annually by the United Nations Environment Programme. And we know, moreover, what the impacts are that are anticipated to occur at each of those different scenarios for temperature rises, so for emissions. So each of those emissions scenarios are associated with a temperature scenario, again on the basis of the probabilities of the modelling, which gives us a whole range of impacts, from the damage to coral reefs, which is now occurring at the moment, through to the possibility of extreme conditions, which occur within this range beyond 2 degrees. And current estimates are that we are currently on a trend to between 4 and 6. I'll just go very quickly so that your eyes can absorb them while I'm talking through some of the impacts that are expected at different temperature increases associated with different emissions pathways. So for the impact on coral reefs, these are the various kinds of impacts, and you can see where current pledges take us, and where how far beyond that is for these kinds of impacts, which are now clearly observable. The same is true of sea level rise, where again these are the impacts under different emissions pathways, and some starting figures on crop yields under relatively low temperature increases compared with what we're expected to. With adaptation means that measures are taken to mitigate these effects without adaptation. And so these are very serious impacts. I'm sure these are familiar. And of course, we now do have a very strong sense that these impacts are beginning to occur now. Most climate scientists are very reluctant to say that any particular weather event is related to global warming, because clearly there is natural variations. But we are now seeing events occur which a few years ago were thought to be 1 in 100 events, and which appear to be now occurring once every 10 years or so. This was Hurricane Sandy in New York. This was a map of the US last August when it was in the throes of a very considerable drought. You could see the colouring. The deep red is the drought. This was the severest drought in the US for many years. This is what it looked like. But we also saw similarly extreme events in China. This was in Beijing, in Pakistan. So this is not deforestation. This is the Amazon. This is drought in the Amazon. This is a riverbed. And in Europe, people may remember the 2003 heat wave, which caused a very large number of deaths in Europe. So these are the impacts that we are already familiar with, and the projected impacts. This is the way the insurance industry understands these, with a huge increase in catastrophic losses from catastrophes of various kinds over recent years. Now, we mustn't think that nothing is happening on climate change. One of the real errors that people make is, because the situation is very, very serious, and because emissions continue to rise, and the projections are so serious, that people think nothing is being done. Things are being done. And I just wanted to show you a few slides so that you're not too depressed by the time I get on to the main substance. Investment in renewable energy is rising much more strongly now than fossil fuels. So gross for net investment, that is replacement investment, right, here of fossil fuels is now less than renewable investment. So there is more investment in power in renewables than there is now in fossil fuels. And fossil fuel investment as a proportion of new investment at the top lines, as a proportion of total investment, is on a very considerable rise. The cost of renewables is declining rapidly. This is the cost of solar power. We've got much, much better fuel efficiency standards in cars throughout the world. We have carbon taxes and emissions trading schemes being introduced throughout the world. We even have most American states having now introduced some form of renewable energy standard. Unfortunately, none of that is affecting the rate of, to a sufficient extent, the rate of emissions growth. And this is the reason why. Because even while all this renewable investment is going in which energy efficiency and so on is rising, you have a very considerable increase over the last few years of coal production. So coal production this year is up 30% and is on this trend under current policies in countries around the world. And this is a picture of the Canadian tar sands. People may have seen this. So this is the new development of unconventional oil, which is now proceeding apace not just in Canada, but tar sands are being opened up in Africa and elsewhere. And there is new drilling for oil globally. Around $674 billion worth of new investment in fossil fuels. Of that, nearly $600 billion in oil and gas, in new investment expenditure, just in the last single year. So this, I think, tells us what our fundamental problem is. Investment in renewables and energy efficiency, all the things which we know reduce emissions, are not sufficiently countering the fundamental growth in fossil fuels. And it is fossil fuels whose emissions contribute much the largest component of total global emissions, which are contributing to this continuously rising atmospheric concentrations. And we can now understand this, I think, in a very interesting way, as a result of work done by a very small NGO called the Carbon Tracker Initiative, in association with my own institute, the Grantham Research Institute at the LSE. To understand this, I'll take you through this, we need to understand the concept of a carbon budget. If you think about what it will take to stay within a 2-degree threshold, a simple way of understanding that is the world cannot absorb more than a certain amount of carbon dioxide along with the other greenhouse gases if we are to stay within a 2-degree pathway. Once the atmosphere contains more carbon dioxide than a certain figure, then 2 degrees becomes impossible. The atmospheric carbon dioxide and other greenhouse gases will so warm up the planet that we will exceed 2 degrees. Now, we can never say an exact amount of carbon dioxide equals 2 degrees, so we have to talk about the probabilities. And we can talk about a 50% probability or an 80% probability of exceeding the 2-degree threshold. And that probability is derived from the climate models and the spread of results you get in the climate models. So these are the figures for an 80% chance of avoiding the 2 degrees. And this suggests, on this analysis, that there was between 2000 and 2050, 886 gigatons of carbon dioxide which could be released into the atmosphere and still give us an 80% chance of holding the world to no more than a 2-degree rise in global temperature and all the impacts that occurs. Of that, this amount has already been burned between 2000 and 2012, leaving this amount as the remaining carbon budget that we have to spend or to use if, between now and 2050 if we are not to exceed the 2-degree threshold. So I hope that is reasonably clear what that means. You can now see what these bubbles are doing. These are the total fossil fuel reserves that are currently known, and not just known, but owned in the world, measured in their gigaton of carbon dioxide emissions potential. Essentially saying that if they were all burned, This is the total amount of carbon dioxide which would be released into the atmosphere. This is our remaining carbon budget. This tells you a very simple fact, and it is the fact which underlies why we see all those trends in those previous slides. And it is because if all of this is burned, we cannot stay within 2 degrees. And indeed, this total is consistent already with more than 3 degrees of warming, according to the models, on an 80% probability. There is a fundamental mismatch between the remaining carbon budget that the world has to stave off catastrophic global warming and the reserves that are of fossil fuels that are now in the ownership either of nationalised energy companies, about 75% of them, or listed energy companies, private, listed on stock exchanges, around 25% of the total. Just to revise these numbers slightly, those numbers come from a report that Carbon Tracker produced last year. They've revised them slightly, acknowledging that there may be various ways in which we can increase the carbon budget, partly arising from modelling. So it's possible that, in fact, because of the effect of aerosols, there may be slightly more capacity to release carbon dioxide, partly because of the possibility of impacting the amount of greenhouse gases which are emitted from waste and agriculture and so on. So they produced slightly more optimistic versions, and these are the figures that they're now using. So again, for the 2-degree pathway, which is the global goal, with a 50% probability, they suggest that there are now about just over 1,000 gigatons, and for an 80% probability, about 900. So the figures have expanded slightly over the last year, according to more conservative estimates or more optimistic, if you like. But now this gets us to the rub of the argument that I want to make here, which is how the capitalist system, how the economic system within which we live is regarding this, how it views this. Let me just say one other thing which might be occurring to you, which is about carbon capture and storage. It may have occurred to you that carbon capture and storage, which is a way of capturing the carbon and storing it so that it doesn't get emitted into the atmosphere, might impact on these numbers, and it's true, it does, by a maximum of about 15%. So if all the carbon capture and storage that the International Energy Agency thinks could be achieved over the next 50 years is done, and that's quite a big if, that would increase the carbon budget by about 15%. So significant, but doesn't alter the numbers fundamentally. So let's try and understand this one. This is about the listed fossil fuel reserves. As I say, about 75% of total fossil fuel reserves are held by state-owned companies. They are owned by countries and exploited by state-owned companies. They're usually with the participation of private oil companies. But about 25% of fossil fuels are owned by companies which are listed on stock exchanges around the world. About a quarter. These are the total reserves of fossil fuels that are available now to listed companies. And this is the figure, this is the size of the bubble, for the total amount of fossil fuels which are owned by those companies but will take further exploration to get at. These figures known as a P1 and P2 reserve, for those of you who know. So this is the total reserves under company ownership. These are their available reserves. And if you take a pro rata figure for the total carbon budget, which can be exploited, and you say, well, if a quarter of all known reserves are owned by listed companies, this would be their carbon budget consistent with a 2-degree path. This figure here, 225. So on the assumption that listed companies and state-owned companies equally exploit their resources, if we are to stay in a world with an 80% probability of 2 degrees, this is the total amount of carbon which fossil fuel companies can exploit. This is their easily available resources, and this is their total resources. This leads us to a very simple and rather stark conclusion, which is if the world is to stick within a 2-degree path, between 2/3 and 80% of the fossil fuels which are in the reserves of listed companies on our stock exchanges cannot be burned. This is what Carbon Tracker calls unburnable carbon. And yet, if you look at the valuation of those companies on the stock exchanges, those valuations are based on, suitably discounted, the total value of all the carbon that they own. So there is, in this analysis, a very pointed contradiction at work. Stock exchanges of the world, and I'll come to London and New York as being the major ones, are valuing fossil fuel companies, oil, gas, coal companies, on the basis of their total stocks, reserves. But if we are to stay within a 2-degree world, possibly as little as only 20% of those can be burned. This suggests that something is going wrong. One of two things could be going wrong here. One thing, clearly, is that the 2-degree goal is not going to happen. That the valuations of these companies on the stock exchanges are correct, because the world is not going to stick to a 2-degree goal. The other possibility is that the world might attempt to stick to a 2-degree goal. There's going to be a new climate change conference in 2015, which countries are going to be pressured once again to do what they have not yet formally committed to, but have not yet got the policies to do. In which case, these companies are overvalued. And yet what the companies are actually doing at the moment is investing in these resources. So last year, as I say, they spent $674 billion worth of capex expenditure, of investment expenditure, in developing these reserves, which over a 10-year period would be over 6 trillion. And these companies are highly profitable. They are returning dividends to shareholders, which are very considerable, though interestingly only about a fifth of their capex. So they are spending from their earnings 5/6 on new investment and only a sixth returning to shareholders. And when I say shareholders, who do I mean? Well, I mean anybody with a pension. This is where these companies are listed on the stock exchanges of the world. You can see that London takes a particularly large proportion. This is London and New York. This is the interesting figure here. This is the market capitalization of fossil fuel companies on the London Stock Exchange at 538 billion. That is 10% of the market capitalization of the London Stock Exchange as a whole. So for any pension fund which is investing broadly across the stock exchange, 10% is likely to be invested in these companies who, under this kind of analysis, may well be extremely overvalued. So this is a problem, not just for these companies, but this is a problem for anybody with a pension or with any kind of investment in the stock exchange. And it's been increasing. The exposure of the London Stock Exchange over the last 2 years to coal has gone up by, and fossil has gone up by 7%. In the New York Stock Exchange by an extraordinary 37% over 2 years. In the exposure of the proportion of the total market cap of the New York Stock Exchange that comes from fossil fuels. So this is then a contradiction, and there are two ways to look at this. One is, and many of the investors in these companies would say, the reason why we've invested, why we have valued these companies, is because we don't believe that politicians and governments are going to achieve a 2-degree world. And so the problem here is not our problem. It's, well, actually, it's going to be a problem for everybody. One of the terms that's used here for assets that may not be realizable in the future is they're known as stranded assets. So if you own an asset which you cannot then realize, that's called a stranded asset. And so you could argue that these will be stranded. But if the valuations are actually correct, and if the people who are valuing these companies are correct to say we will not achieve 2 degrees, then some other assets will be stranded, which is all the assets of the cities which will go under with sea level rise. The majority of people in the world live on cities. All the assets of power companies which will be subject to flooding or drought and so on. All the assets of the agricultural industry which are dependent on levels of climate change not rising above 2 degrees. So we have here two different scenarios for a stranding of assets. Either the assets of society at large will be stranded very severely, or if we do manage to hold global warming to 2 degrees, the assets of fossil fuel companies. Let me just make a really critical point here. These are the figures for a 2.5 degree rise or a 3 degree rise. So you may think, well, look, there's comfort here in the fact that perhaps we could survive a 3 degree rise. Now, if you look at the impacts that occur on 3 degrees, they're horrific. In practice, this doesn't affect the maths very much. But once you go beyond 2 degrees, you very quickly, you don't need much additional carbon to get you to 2.5 and 3 degrees. So even if the world manages to keep this at 3 degrees, which would be pretty terrible, I mean, seriously bad, this is still a very considerable divergence between the total valuation of these companies and such a scenario. This analysis, which was published just a couple of weeks ago, I think gives us a much clearer sense of what is at stake in climate change than we've had previously, because it makes clear that it is at root the burning of the fossil fuels which causes the problem. And no amount of slowing down of that burning will solve the problem if ultimately it is all burned. And this, I think, is a really crucial finding, because it doesn't matter in the end how quickly the carbon dioxide goes into the atmosphere. If it goes in there, it will cause the rise in temperature, and it may delay it by a slowing down by 10 years or so, but we will still hit those temperatures and then those impacts. This tells us that the only way to solve climate change is to leave the fossil fuels in the ground. But this equally tells us that the way capitalism is currently operating, not just that these fossil fuels are being exploited, but that our stock exchanges, which is the basis of our pension system and of the value and of the considerable value in the economy, is based on that exploitation. And there is going to be some kind of reckoning, either the reckoning of climate or the reckoning in the valuation of these companies. Now, we can talk about how likely it is that we will hit the 2 degree trajectory through public policy in countries around the world. We can talk about how likely an agreement is that we'll achieve that in 2015 or later. I want to take this discussion into a different direction, because I want to explore what this means about the way in which capitalism works and how we think about it. Carbon Tracker have not surprisingly described this analysis as showing the existence of a carbon bubble. And they pointed out that the risk here is a kind of systemic risk. That is, so embedded is carbon within our economic system, and so central is our fossil fuel companies to the valuation of our stock exchanges, that we should see this mismatch between the 2 degrees trajectory and the reserves that they hold and their value as a form of systemic risk which is occurring in our economy. A risk which, if it is realized, will have a huge shock impact because of its scale and because of its pervasiveness on the economic system as a whole. But this, of course, is not the only systemic risk that we are now facing. In the financial crash in 2008, we became aware of a different kind of systemic risk also being incurred within the economic system. The great crash of 2008 was caused because financial institutions took on securities whose value they did not properly understand, and which had embedded within them much greater risks than they had realized. And when those risks became real through the subprime mortgage crisis in the United States, and elsewhere as property bubbles on which many of these securities were based burst, that left the world's banking system and financial institutions on the verge of collapse, as we know. And they were only rescued by huge injections of public expenditure. And we are now suffering the consequences of that, because obviously austerity is an attempt to try and restore the public accounts, which were hugely affected by the injection of capital, which went in to preserve the banks. And what was going on there was the in what we can now see was a kind of systemic risk, which was taken on by the financial sector, which had a huge impact on the economy as a whole, because the financial sector had become so large in relation to the rest of the economy. And we heard the phrase that the big banks were too big to fail because of the impact that they would have on the rest of the economy. Despite only being a relatively small proportion themselves, their impact occurred throughout the economy. These risks, it must be recalled, were explicitly endorsed by most economists, who thought that by dividing up the risks and sharing them out in a very dispersed manner amongst a whole range of financial institutions globally, and that was what the parceling out of different securities effectively was, they thought that that process would reduce the risk. This was the theory most famously expounded by Alan Greenspan, the chairman of the Federal Reserve in the US. I can remember him coming to London to expound this theory in about 1999 or 2000. I have to say I was rather sceptical at the time. And we now know, of course, that he has acknowledged that his theory, as he famously put it in his testimony before Congress in 2008, had a flaw in it. You can see it on YouTube, his testimony. It's quite amusing in a grim kind of way. The flaw in the theory was that efficient markets would not indeed reduce the risk by spreading it widely. They would merely increase the contamination of the whole economic system by ensuring that every financial institution was exposed to it. Now, what do we learn from this? Well, firstly, we learn that systemic risk is not a phenomenon solely within the financial sector or indeed within the carbon sector. This is now something which we can see in both of these sectors, where the risks taken on by the expansion of particular sectors within the economy, which have very pervasive impacts on the rest of the economy, can then destabilize the whole. Which tells us that we need to understand capitalism, the economic system we live in at a systemic level, and not simply as a series of disconnected markets. Microeconomic analysis, which deals with separate markets, is obviously valuable, but it must be supplemented by an understanding of the systems as a whole, and the way in which parts of a system can nevertheless impact on the whole. And we've seen this both in the finance sector, and my suggestion here is we are seeing it now within the carbon sector. This is particularly important for environmental economics. Most environmental economics has been a form of microeconomics. It's been concerned with the particular pollutants and resources and their analysis, the analysis of externality within microeconomic markets. But carbon, and the point about carbon is it's pervasive. Carbon occurs in more or less every transaction that we do in the modern economy, minus those relatively small still parts of the economy that are powered through renewables. And so the carbon nexus goes right throughout the economy. And so to understand climate change, we have to understand the economic system as a whole. This pervasiveness, allied to the logic of expansion, which is one of capitalism's primary dynamics, creates, in these cases, systemic risk, where that expansion goes beyond the safe thresholds for the whole system. And this will happen unless it is actively controlled and regulated. We now know, and it's become painfully clear after the event, if it wasn't during it, that the financial sector was heavily under-regulated in this period. And regulators did not understand these risks properly and did not control them. And we now know that carbon is also severely under-regulated. There have been, as I said, attempts to do so. We now have carbon prices in many parts of the world. But the European carbon price is now under €4 a tonne. The European emissions trading system is on the verge of collapse because the economic slump meant that there were far too many permits in circulation. And our regulators have not been willing, in exactly the same way that they were not willing to tighten financial regulation as the expansion of credit and the use of derivatives and other obscure securities grew in during that long boom period, as they were not prepared to tighten regulation of the financial sector. They have not been prepared to tighten regulation of the carbon sector. And the result is that Europe, which has very strong emissions targets to reduce its emissions by 80 to 95% by 2050, is now seeing a huge growth in coal use. So the most polluting fuel is now on the heaviest rise in Europe, gas plants being mothballed because they are uncompetitive now with coal. And this is a severe failure of our regulators, of our, if you like, our carbon regulators, to control this expansion in fossil fuel use, in a way that is very similar to the failure to control the expansion of financial instruments in the previous period. This creates a huge policy challenge, and we can talk later about the policy challenge for us. But it's also a challenge for orthodox economics, which continues to see resource throughput as invisible. By measuring value in the economy simply through monetary exchange, most economics has failed to understand that economic activity is based on the throughput of energy and material resources through the economy. This is 40 years after Rugen, the pioneer of modern environmental economics, presented his analysis of the thermodynamic basis of the economy. We still don't really understand in mainstream economics the dependence on resource throughputs and the pressures that is putting on the economy. And carbon is one very, very strong pressure now, and the pressures of climate change, but there are many others. Over the last 10 years or so, resource costs in the economy, global economy as a whole, have been rising at about 7% a year. They've contributed probably to additional costs on GDP of about 4%. The figures on resource prices, on commodity prices, are extraordinary. There was about a 100-year fall in commodity prices up till about 2000, since about 1900, which has completely been wiped out over the last 10 years as resource costs have risen, under the pressure of huge demand, mainly from China, but also from other growing economies, and restricted supply. And this has put huge pressures on the global economy. It's one of the reasons why the global economy is not growing as fast as it did in the past, because resource costs are rising, are absorbing a very considerable proportion of GDP. Largely unseen by macroeconomic analysis, which hasn't understood the particular basis of this. Similarly, most macroeconomic models have not properly understood the financial sector. It is a rather extraordinary fact that the majority of macroeconomic models in use by macroeconomists, stochastic general equilibrium models, don't have a financial sector in them. The financial sector has been seen by macro models as a cipher. It is simply the vehicle through which money flows between borrowers and savers. There is no financial sector. And then, unsurprisingly, the behavior of the financial sector is not then modeled. And of course, then it becomes easy to see why macroeconomic models did not understand and did not predict the financial crash. You may remember a few years ago, you may not, but I remember it as I was at the LSE. The Queen came to the LSE and, in her inimitable way, asked the assembled economists why none of them had predicted the financial crash, a question which they were not prepared for. And very few of them were willing to explain. But actually, there is a very good reason, which is that if you don't have a financial sector in your macroeconomic model, it becomes hard to see how the behavior of that sector can influence the wider macroeconomy. This is now being repaired. Much of the most interesting work now being done in macroeconomics is now trying to model the financial sector. And surprise, surprise, if you model a financial sector and its behavior in response to different monetary and financial conditions, these macroeconomic models become much more unstable, which perhaps is not such a surprise after all. What we have here, what I'm suggesting, is that there are parallels between the failure of orthodox economics to understand the resource base of the economy and the way in which energy and materials flow through the economy, and the particular kinds of impacts that those flows have on the wider macroeconomy, both through climate change and through other resources, and a parallel with the way in which a failure to understand the financial system has also impacted on economists' understanding of the wider economy. But there is a deeper question here for us too, I think, which is the impact in which economic ideas have had on our political system. Over the last 30 years, economic thought in political and public debate has been dominated by a set of ideas about the economy known as neoliberalism. These have essentially argued that capitalist economies work best when markets are left as free as possible and as unregulated as possible. And they generate the greatest welfare to their citizens when markets are allowed to operate with as little interference as possible from governments and the state. And this view has become extremely dominant over the last 20 to 30 years. 30 years ago, it wasn't completely dominant. There were many economists who challenged this, but there has been a kind of hegemonic restriction, I would argue, in the kinds of ideas about what is good for our economies. Not least because many of the forms of state regulation intervention didn't work, and so it's, in one sense, you can see why people wanted to argue that markets were best left to their own devices. But if we look at the record of less regulated markets, it's been a pretty terrible one. Mostly the Western economies have grown much more slowly over the last 30 years as these ideas have been largely dominant than they did in the previous 30, when states were much more involved in economic management. Now, there may be many reasons for this. Obviously, economic circumstances change, and so that is not in itself decisive. But it is a rather interesting phenomenon that the growth rates were so much better in the period of much stronger government intervention. But in fact, the results are even worse than this. Because if you look not at the overall growth rates, but at the distribution of income, the last 30 years have been pretty catastrophic for Western capitalist economies. The US economy has had the extraordinary phenomenon that incomes below the third quintile, third 20% of the economy, have stagnated or declined. The bottom 20%, the real incomes, have declined by 30% over the last 30 years, while the incomes of the top 1% of the population increased by over 120%. This is not an economy which, for most people, and literally for most people, has been performing well at all. In the UK, the figures are less than this, but over the last 10 years, you have a very similar phenomenon of stagnant real wages for the majority of the population, while a very small number at the very top have grown very rich. And if you look at the next 10 years, the projection of the next 10 years, the British economy shows the same. So, in many ways, you could say these have not been very well good performing economies. And on top of this, we've obviously had the financial crash, which was not predicted by neoliberalism, and obviously can easily be seen as a result of the deregulation of markets. And now we have the potential for a carbon crash of the same kind. There is a very interesting question as to why, if the performance of economies under neoliberal prescription has not been very good, why neoliberal ideas have had such a hegemonic impact in society. We can discuss this. My own view is that it's best not to think of neoliberalism as an economic theory at all. As an economic theory, it rather underperforms against the evidence. However, it is a good piece of politics. And it is best understood, in my view, as a very, very good device for enriching the already powerful. And that is, in fact, the evidence of the application of neoliberal ideas, in which the powerful and elites in society have become very, very much richer and more powerful over the very period in which neoliberal ideas have become hegemonic in this way. And I don't think that is a coincidence. And I think we need to be very careful not to think of ideas as having some kind of free standing in their own right, but that they are attached to social and political forces. And we can see that attachment very strongly. And so what I want to argue in conclusion is that we need a different set of ideas if we are to avoid the worst effects of climate change and of the social impacts which we can also see in our present economic system. Instead of seeing capitalism as the locomotive which pulls society along from outside, we need to see our economic system as one of the moving parts of the society which we wish to control, an engine under the steerage of society. My metaphor is that it seems to me that we need to understand the economy in its different parts as embedded within wider systems. And I would argue this in three ways. So firstly, I think we need to realise and understand in our appreciation both of economics and of public policy that our economies are embedded within a natural resource system from which the resources and energy comes and to which the wastes flow. And those natural resource systems have limits and thresholds, of which the climate ones are the starkest and the most severe, which if we go beyond them causes serious and potentially catastrophic effects. And we need to constrain the economy within the limits of the natural resources within which it should be embedded. Secondly, the financial sector needs to be embedded within the wider productive economy. What happened over the last 20 years at the financial sector, in a way, loosed its moorings from the real economy, became a very active sector in its own right, started taking on risks which, as we saw, became systemic. We need to reassert the fact that finance should be a servant of the wider productive economy, and to ensure that it's regulated embedded within that economy. And thirdly, I would argue, and this is beyond, in a way, this particular talk, that we need to understand the structures of companies, the ownership of companies embedded within our wider social system. We need to have a much stronger ownership of companies and their direction within wider social systems, and that can be done in a number of different ways. So it seems to me understanding the economy as embedded within wider systems may help us create frameworks in which we can regulate and manage it according to society's stronger values. And here we need to be very clear about one particular value, and this is the value of stability or resilience. We have lived in a world, particularly over the last 20 to 30 years, when growth and the accumulation of within the economy, the growth of income, has become a hugely driving force culturally as well as economically. And we've seen the ways in which that drive to expansion, the drive to increase wealth, has led to systemic risks occurring in the financial and now, I would argue, in the carbon sector. This has profound implications for the ways in which we think about the economy and what we value. Stability and resilience are very, very important values. They are the values of the longer term and not simply of the short term. And we need to find ways of making those values become part of the way our economy and our society works if we are to live within our environmental needs. None of this is easy. Managing an economy will involve a much more active state, and we are familiar with the ways in which states can fail. This is not an easy agenda, but we shouldn't expect it to be easy. We're living in a world in which our desire, absolutely understandable desire for greater material wealth, particularly in the developing world, is now coming up sharp and hard against the constraints of a natural system, a natural resource system, which simply cannot absorb the kinds of pressures of greenhouse gases which it is now being expected to through our emissions profile. And this requires us to have a much more grown-up debate about what kind of economy we want. One in which we accept the need for restraint within our economic system, and not simply for the fastest possible growth. Not simply for the shortest term horizon, but for a longer term horizon in which stability and resilience are given their due weight. Climate change reflects a fundamental conflict, and it is one from which we cannot escape. And we understand what it is to be now, I think, on both sides of this. Our desire for increased wealth and growth, and the finite capacity of the world's atmosphere to absorb carbon dioxide and other greenhouse gases. We can only deal with this by constraining the fossil fuel production, frankly, by leaving most of it in the ground. And that requires fundamental change in our energy and our economic system. But it will also require a change in the way we think about the nature of our economic system and the values by which we wish to govern it.